Maar hij stuurt gewoon, hij is Swiss Is that a presenter or? What? Is that a presenter or what did you? Yeah, also I wrote on my desk list from last week. I was like, it's from a person who's brand new. Super many China. No, Andreas asking, do we have a clicker for that? Yeah, we do. Those one, you have like, you can even switch it, like this is the that way. And so, this one that way. You can put it like, this is black. I will just leave it on. Okay, cool. Well, thanks. That's why.
I would have sat there, but I was thinking that somebody might need it for some sort of like practical purpose. Hi, Peter. As I've said to my Dutch coworkers before, it's Dutch friction. Actually, I am partially Canadian, but I'm originally from Seattle. Yeah, I've been living in Sweden. I live in Sweden. I've lived there for about 7 years. You can put up the money transfer people, and so on. So this week I was booked for something else here for Microsoft. I'm just here for work today. So I happened to be in town and I was like, show up. But I've so now you can't really, Skånska, you could make just as much shit of it. I'm actually, Danish is probably more intelligent than but I'm honest. Yeah, I understand. Well, my office right now is out of Oslo, but I'm moved to the Danish office only because they have a better room selection. And, no, it's basically like they have all the our office in Denmark, they have the selection of natures, like all the juice, the Danish juice stuff. Oh yeah. No, it's in Stockholm, and in Stockholm it's usually government offices always have box No, it's the box wine IPO. That's what it is. Actually, there's a friend of mine who's a rubber. Well, also you can just do it. Mine doesn't speak. I don't drink. I don't do coffee. I don't eat meat. My purchase, I just tell friends of mine to drink it, smoke and all that, and I'm like, I'll have your cigarettes and your alcohol for you when you're it's like, because I'm having a good time with them, it's just like, notice it. Yeah, probably. Oh yeah. No, and you wake up in the morning and feel good that you're awake and feel good, have your body feeling good most of the time, and that's very valuable. Even though it's between me and sleep in social situations, sort of doesn't matter where people look at me. But, yeah, what's wrong? Actually, The interesting thing about that to me is the idea of go back to this idea of a bunch of friends of mine who are in the security room trying to think about all this energy is going into Bitcoin mining, you know, the cryptocurrency is going to become really rich, and I'm sitting there going, okay, banks, data centers, all of these different things, and they're still funding those. I mean, like, that's the thing about it, is that most of these companies will never put in what they need to do to secure going forward.
Hello? Oh, good evening. Good evening, everyone. It's very exciting to have you all here in this beautiful place to talk about IOTA for an evening. And to start, since we most probably don't know each other well already, I will ask you to shake hands with your neighbors. Just say hi. My name is X, and okay. So now we are all set. Good evening. My name is Maxime Bouillon. I'm your organizer and host for tonight. And together with some amazing speakers that we will have during the night, we will make our best to provide you with an exciting evening. So without further ado, let me welcome Andreas Ozowski. With some warm applause, please. Andreas will introduce you the Flash channel, and I think that's all I have to say, and I let you the ground.
Thank you.
Andreas.
So, hi everyone, first of all. I'm Andreas. I'm one of the IOTA core developers based out of Berlin. We've been working on IOTA for, well, the better part of a year by now. Anyway, let's get started. So first of all, it would be good to know who here has seen, well, who here has been to the last meetup? That's a good number. Nice. All right, so what I'll be doing tonight is I'll essentially be providing you with a quick overview of what's IOTA, what we're trying to, what we're trying to achieve. And once that's done, I'll be doing a deep dive into the whole Flash channels thing that we've released last month. And then hopefully give you enough inside knowledge of how these actually work so you can go on and explain it to someone else as well, and maybe even participate in our Flash hack hackathon. So let's get started. How did we end up here? What was exactly IOTA? How did this come to be? So back in 2013, 14, like the founders behind the IOTA project essentially realized, you know, this is traditional blockchains, Bitcoin, Ethereum, are just wasn't around back then, but whatever, isn't really gonna solve the challenges that the upcoming machine-to-machine economy will require. So we need something that's very lightweight. We need something that is able and that can be easily used by machines, and that also facilitates the whole Internet of Things storyline. So that's how IOTA came to be. IOTA is essentially the Tangle, which is what we call our directed acyclic graph, which encodes the whole transaction structure, and it's going a step beyond blockchain because it's essentially a blockchain without the blocks and the chains. What exactly does that mean? So this here is a quick, you know, one visualization of the Tangle, where you've got all these different nodes in there, and these can be either transactions or bundles. Let's just go with transactions for now. And each of them confirms 2 previous transactions. And thereby you have a very large amount of possible growth. And whoops, it's not a blockchain because there's not a sequential line of transactions, but there's lots and lots of growth. There's a white paper which is currently in our 5th version or something like that, and we're continuously updating that as well. Now, our main features, as I said, we came from this thought, we want to enable machine-to-machine payments, we want to enable the machine-to-machine economy. So we've got 2 things going on. Of course, this is still a crypto thing, so we need something that has a very cryptographically secure and cryptographic integrity guaranteed as part of the system. And we also need something that enables machine-to-machine micropayments. How did we achieve this? Few things, I'll just run through them quickly. So first of all, there's no transaction fees. If you send someone $1 send or $1 single IOTA token, that other person will receive that same IOTA token. That's possible because there's no miners. Then there's also, because of the whole structure, because we don't have these mining pools, if you look at Bitcoin at the moment, there's like 6 or 7 which control 70% or something like that of the complete hashing power. So you've got a certain amount of centralization. And with us, the more the network grows, the more participants you have on a network, the higher the whole and global and total scalability goes. And at the end of the day, there's also the whole thing about partitioning. Like, you can actually split our network into different small chunks. As long as you keep them in sync, you will be able to merge them at a later point in time, thereby allowing you to do transactions without even having any internet connectivity. Of course, we have to be honest, our whole approach is based on the fact that we need a large enough network to be self-sustainable in the decentralized consensus way. In the past, well, up to date, there have definitely been more than 15 billion US dollars transacted using IOTA tokens, which is pretty awesome for us because I think we only got listed a couple of months ago on Bitfinex, and since then this thing has taken off exponentially. But you know, I've told you how we ended up here, and my thing doesn't work. Okay. The laptop doesn't work. Harm? Oh, that's quite a bit too far. Lovely. All right. It's working. It just got hung up. So I wanted to tell you a bit about who are we. Like, it's not just me. I mean, as I said, I only joined recently, but there's a lot of other stuff behind it. So first of all, IOTA is being run and developed by this IOTA Foundation, which is a registered non-profit organization based out of Berlin, Germany. So we went through all the legal hoops and everything, and it took us until November this year to get that registration finally pushed through. The IOTA Foundation is entirely funded by our own tokens. So there's hardly any or pretty much none fiat investment happening here at all. So we thrive and we depend on ourselves doing a good job, and hopefully, you know, not just the crypto community picking up on us, but also lots and lots of business partners who are doing real-world projects with us. And at the core of IOTA, there's a team of, well, about 9 people. I'm down there in bottom, and we are globally centralized. We currently have got about 24 developers and, goodness, a certain amount of researchers, 16, I believe. The number varies a bit every week. And we are also, you know, because we know that we can't do the full security on our own, we also contracted some cryptographers who are world-leading experts in the field of lightweight cryptography. And we've got offices not just in Berlin, where I'm based, but this presenter, but also in Tel Aviv, where we're getting more and more people on board, Oslo, Chicago, and quite a few other places around the world. If you're looking at a world map, we're probably centered around Europe, Tel Aviv, and Australia at the moment. So we think that permissionless ecosystems are the future. So, you know, let's use IOTA, let's empower everyone, because you shouldn't be dependent on others to do the stuff that you want to get done. So, our vision, apart from, you know, machine-to-machine payments, why are we here? Why do we do this? Because at the end of the day, we will not just have, we will have a machine economy. And what does this mean? This means that, you know, we won't have the dumb decentralization of the past, where, you know, you had your no connectivity, these devices were just monolithic repositories of data, but there was no way to exchange data. Then what we've got at the moment, so to speak, is smart centralization. You've got your smart devices, which always talk to one central cloud, and thereby achieve some purpose. But, you know, if your remote control provider switches off their service, all of a sudden in a couple of months' time, then you're just screwed. And we're really thinking that this will change and go towards the way of smart decentralization, where you will have all these local clusters where decisions happen, where transactions happen, where logic happens. So everyone will be surrounded by their own little cloud. And well, you can build on top of IOTA already today because, let's face it, smart decentralization is a thing that will be here in a few years, but is not here yet. Some things that are, for example, the data marketplace, which Harm will go into more detail on in a bit. The whole Industry 4.0 aspect, which is already starting to kick off, where you have got machines on your factory floor which you control, well, which you need to control, but at the same time you also want to have some kind of audit log that gives you an overview of which commands were sent to the machine and gives you this overview without any party that's potentially involved in the process being able to alter the whole system and provide you with inaccurate data. Other things, OTA updates. So, for example, you send an update to a device. You want that update. You want the device to persist an update log, to persist state changes. This is very relevant for regulatory cases where an insurance might not pay out for someone when this person hasn't updated the device to the latest version, or producers might be liable for things. Who knows? So we enable this audit trail facility, but on top of that, of course, there's also the whole stuff like, you can have devices where you can opt in for specific features for a limited amount of time by sending them funds in the form of IOTA tokens. However, now let's get down to what I'm supposed to be talking about this evening, which is IOTA flash channels. What are flash channels? Essentially, they're state channels the IOTA way. These work by where you have your group of parties that want to set up this flash channel, so they decide to set up a multi-signature address. Then funds are sent into this channel, and they have to be confirmed by the network, so the channel has to be funded. And then you can do all of these lots of transactions off the tangle. So without going the full round trip through the consensus algorithm all the time, by essentially each party signing individual transactions all the time, and at the end of the day, you close the channel. Easy enough. Now, I didn't say that, but on there it says you have to decide how many transactions should fit into a channel in the first place. So the way these flash channels are built is essentially, after you've exchanged your multi-signature signatures, digests, so you can create a final multi-signature, you also then need to create a certain number of addresses, which is what the channel consists of. So for example, this channel here, this can contain 16 transactions in total. 16 because you've got 16 leaves of this binary tree. And what's happening here essentially, so for example, you've got Alice who wants to do a flash channel with Bob. Now, they set up their multi-signature stuff. They generate 31 addresses. And they generate 31 addresses, and then they send a specific amount of tokens into the initial root address, which is address 1 right up there. Now, when they then suddenly start sending tokens to each other, or when they send tokens to a third party, what's happening here is essentially they start moving, and this is guaranteed by code. They start sending tokens to the next hop in the tree all the way down to the first leaf. And thereby, they can actually always redecide where they're going to send tokens without having to re-sign everything. And because each of these individual addresses up there is always governed by a multi-signature address, you have always got some kind of proof, or it's just a fact that no one can touch those addresses other than the group that decides to do the multi-signature wallet address, be that fully M2M group or M2N, where you can only have 3 or 4 parties that are required to sign a specific transaction. Now, once you've then got these bundles, once you've then got these transactions, and then you always move to the next leaf until the flash channel is done or whatsoever. What then happens, because none of this has seen any kind of proof of work happening, is you take the final bundle usually and attach that to the network. Once that happens, the flash channel is closed. There might be some funds left in one of these higher level addresses, But in that case, you will need to figure out how to resolve this with your Flash channel partners at some later point in time. And yeah, that's how easy it is to send funds in and out of a Flash channel. We've got quite a few graphs on our blog post that illustrated this. I didn't want to bore you with them tonight, so I just picked one, which also, again, elaborates and elucidates how to make a single transaction. So essentially, we've got demos for this. There's Eva and Yannick, not Alice and Bob tonight. So the first one proposes a transaction, and that proposal is transmitted to the other party or all the other parties using some side channel, be that a WebRTC connection, a WebSockets, Bluetooth, whatever you want to do. It's really up to you. Then the other party has to agree on it and also sign the proposed transaction. And because we're talking about multi-signatures, so no one holds all the keys to these addresses, you need to generate the complete signature in parts. So you always need to round trip between the different participants and need to do all of this in order. And once all participants then have agreed and accepted to do a transaction and signed, and the bundle and the transaction is fully signed, then you've completed this transaction in terms of Flash channel transactions. And after that, you continue doing this. You eventually close the channel. Someone might screw you over because if you're, for example, agreeing to pay on a per kilobyte level when we're talking about internet streams. So think of the scenario where you're on a plane. At the moment, if you're buying Wi-Fi for the full flight, you're probably paying around 24 euros. You might have shitty connectivity, so those 24 euros might be wasted. Who knows? So what Flash Channels offers you and enables you to do here is essentially you can have this contract set up between you and the provider where you just send funds 1 kilobyte at a time. And because you don't need to do the round trip, because you don't need to do proof of work, which is at the end of the day a certain computationally expensive process, you can use Flash channels instead. So I hope that you've got a better understanding of what Flash channels do. If you don't hesitate to ask later on or find me later on this evening. But I wanted to also tell you a bit about where else. Oh yes, sorry, there's a video. Video kann nicht worden geladen. Yes. Let's see. I'm just going to refresh this. Okay, we don't have internet. We don't have Wi-Fi. Yeah, the internet is broken. That's when you depend on centralized clouds and don't have everything locally. But anyway, so what I'm going to show you is this Flash channel demo, or a video of it whenever we've got internet. It's working. Yay. It's just stuck because the images are too big, I guess. Well, one would hope that all these services do that for you, or that they deliver more efficient. Yeah. All right, there we go. So I wanted to show you this video of this happening in action. There's a demo which you currently have to download yourself because that deployment is broken, but we'll fix it tonight. So what's happening in this video is, you've got your two parties who've got two different browser windows open, and they fund a Flash channel. This is all running on the testnet in real time at that point in time. And they start funding this channel, and this channel is funded with 2,000 tokens. So while they've got also this chat thing, they can just decide to move tokens to the other party, and the other party has to agree or to refuse a specific transaction. And this happens quite quickly. It's mostly just limited by the amount of time it takes you to do a signature. And then, eventually the whole channel is then closed. You do proof of work right in your browser using WebGL, and the transaction is sent off into the network, and it will be picked up, and then the value change will happen. And there's also some other demo that we did together with Satoshi Pay, where the idea behind it was to demonstrate that you can also have all of these lots of microtransactions happening for web page contents, where you fund a channel with a specific amount of tokens, then you click on an article, you pay for it, the server sees that you've signed a transaction, so it knows that even though the transaction hasn't been attached to the network, it can always do so itself, but it can also just release the content to you, because it owns the full signature. It owns a fully signed transaction for the specific transaction where you move tokens to the data provider, content provider. I'm not lucky tonight.
Using blockchain for that?
Huh? Right, so I also wanted to all right, so at the end of this, at the end of talking about Flash channels, I wanted to talk about this competition that we're currently running called Flash Hack, which is a virtual hackathon which is running until the end of January, where we're dealing out a bit of prizes for users and for community members who are developing awesome solutions on top of Flash channels. There's a few prizes. This right here at the bottom is where you can find the Flash library. There's a dedicated channel to this on our IOTA Tangle Slack, where you can inquire and find teams, do whatever you want to. We're open for really anything here, and there's no categories to fit. So after Flash, where else are we going with this? So there's MAM, which you might have heard about, which Harm is going to talk about in a few. But of course, there's also other stuff. There's mystical stuff, which I'm not going to elucidate on tonight, which is key. There's the Trinity wallet, and I've heard earlier tonight that there's also Carrot BRICO tokens, wherever those are. Then there's this whole idea of enabling private transactions on top of the Tangle just as well, which will be done via Tumblr. We've released a research white paper on this, and we're also in the process of implementing this further. However, oh yes, and there's also an ecosystem fund, because we've got tokens to spare, I guess. You should probably add a 0 to that, given our current valuation. But we're also still accepting projects here, so we want people to start developing on top of us, not just big companies, but we also want a community to form and people doing applications because they want to. However, for now, let's end with questions. I think I've got a few minutes.
Sorry, question will be a bit later.
Okay, questions will be later.
The evening, actually. We have a few more speakers, and we'll have a session of Q&A afterwards. So hold your questions, write them somewhere if you like. But thank you. First, Andreas. I hugely apologize for your lacks of internet. We will have a small break right now of, say, 10 minutes. So we come back here at 10 to 8. We have 2 bars open. One is downstairs and the other one is upstairs. So you can go to both and not overflow just one of them. And if you're online, take a break also. And we see you in 10 minutes.
Was that this? But is this the only break? Or?
No, there are more. Every single break is an interview.
Yeah.
So yeah.
No problem.
Sorry. I will ask at the next break.
No problem. But I can also add people now. But just 5 minutes or something?
No, it will be 15. It's like we start at 5 to 8, so you have time to do a small interview.
Check out a good location.
Yeah. Also pin me next time. Pin me. I'm here.
Okay. Yeah.
Then I can show you like this is Martin.
I'm gonna wave and do a dance.
Yeah.
Thanks.
Okay, cool. Sorry.
No problem.
Yeah.
daar gaan we niks...
You're starting to see this stuff happen. It's just a matter of how clean it is and how well.
Stop van de word, is it? And we put the backup laptop here. Because it's only backup.
You can also send it to me.
Yeah, but we have to make it there.
If I know that I can take a good news site and we pick up a good rate and then I can actually make money doing it, it makes it a hell of a lot better for me if I want to do something. I can just like a lot of that good content. It's like
Perfect, thank you very much.
Stairs there.
Yeah, it's on. Of je hem dan pakt, want je hebt hem dan ingesteld, maar hij is weer uit.
One, two. Good evening again. Oh, that was loud. Thank you. Thank you very much. So, to continue with our evening, we will have Harm van den Brik, I hope I pronounce it well, who will introduce us to
MEM and Data Marketplace. Thank you, everybody.
Well, I'll leave you the stage then. See you soon.
Thank you. One question first to start with. Who is actually present in the Slack of IOTA? And who is present in the speculation channel? Cool, cool. Another question? Raise your hand. Carrots or potatoes? Carrots? Okay, good one. Good one. Okay, let me start with MEM, mask authentication messaging. I think this enables also cool applications using IOTA, and I think this is why IOTA enables these cool applications, because IOTA supports more than just only a cryptocurrency, like for example you have with Bitcoin. That's also the reason how I got interested, and together with JP, interested from an access point of view. It's a Dutch grid operator. That's also why we started building a charge station, which we showed the last time, because IOTA is more than just cryptocurrencies. It's also data transfer, secure data transfer, and that's what MEM is about. So it's about data integrity and secure and authenticated messaging, even encrypted if you want to, and it supports forward secrecy, and that's the cool thing. So what I said, because you don't have any fees, you also can send data around without paying any fee. So before you just send a value, and now you can send data. You can send actually as much data as you want to, because you're not paying any fee. And because you're not paying any fee, and you add the data to the Tangle, and you make a transaction by doing so, you actually help the network. Andreas showed you this picture too, and I'm showing it again, because if you create a data transaction, so storing data into the Tangle, you just create a normal transaction, but like I said before, it's a zero value transaction. But it helps the network because it confirms 2 previous transactions, and you add it just to the Tangle just as a normal transaction. So what is MEM about? MEM has 3 different modes, and these modes, you can use them in different use cases. The first one is the public mode. Well, you have non-repudiation, onweerlegbaarheid in Nederlands, which is you sign a message, and because you sign it, you give others reason to believe that the one who sent it out actually is the one who sent it out, because it's the only one who can sign it. And that's the same thing with MEM. If you send a message out, so some data, you actually sign it using your seed. And because you are the only one who knows your seed, somebody can know for sure that it was you who put it on the Tangle. And if you open that stream, all the messages in there can only be put in that stream because the guy owns that seed, put it in there. So that's something to think about. If you give somebody, and we will discuss it later, and I hope everybody brought a laptop because we're going to do some programming too. Because you get a root, which is an address in the public one, you can find all the next messages in the same stream. And the only one who can send that message to that stream is the one having the seed. Then you have the private one. The private one is kind of the same, but it hashes actually the root you use to find that address, to find that message, and the hash of the root becomes the address. So you can't revert it back to the root. And you need actually that address to unwrap or to get the data decoded some way to get it back out of the Tangle. So this allows to make sure that nobody can deduct the root out of the address, and you actually need the address to unwrap the data in it. And the restricted one, which is also used in the data marketplace, that's why I'm telling you, it uses also an encryption layer on top of the message. So all of the data gets encrypted symmetrically, and with this symmetric encryption, nobody can read the data in that message. So even if you can find it, for example, in the Tangle Explorer, you can't read the data because you need that key to decrypt it. So this allows for some kind of use case, for example, with charge stations. Because if you can create a stream, somebody can fetch. You can send data, for example, if a charge station is available or not, to that stream. And people can know for sure that it was you who put it, so the owner of the charge station put it on that stream, because it's the only one who is able to do so using the seed. And this allows, for example, for navigation software, so they can connect, for example, to that stream, get the data out, and use that data in their navigation software to show if a charge station is available or not. Maybe in the coming 5 years, more people will drive electric, and that becomes not a problem, but a challenge to find charge stations which are not occupied. This, for example, could help in that. And why I'm telling you this, and why did I start with MEM? Because the data marketplace actually uses MEM, mask authentication messaging, for enabling the use case with the data marketplace. And I really like the data marketplace. I also had, made a demo with it, which I will show you later. And I can also show the temperature in here, and you can look it up yourself. But the data marketplace is about sensors. So we have a lot of sensors in the world. Usually the owner of the sensor gets the data and doesn't use it in any way. And the marketplace allows to sell that data or to make that data available also for free. So you don't have to pay for it, you can also access it for free. And the way that's done is that you have that sensor, you put it on the Tangle, and the data marketplace shows the sensor in this map, for example. But later on, this could be also machine to machine. But now you can actually find this if you go to on your laptop to data.ioda.org. You can see the same screen. And for example, the last time we showed the charge station is also in here. It's located in Arnhem. And the charge station, if you buy it, so you have to fund your wallet on the top right. You can see it there. And you have to fund your wallet, and then you can download that data or get that data if you pay for it. And this is on the testnet, so no worries, you don't have to pay anything. It's just test tokens. And if you paid, you get access to the stream. So you get access to the actual data stream. And the actual data stream in here shows if the charge station is available or not. Did somebody already see the live demo on the data.ioda.org? You are trying the laptop? If you go to Amsterdam, you will find this sensor. This is a Raspberry Pi. It's in here. I'm not sure if the cameras can see it, but it's a Raspberry Pi with a sensor. And this sensor is measuring the temperature in here. And I can tell you, I watched the stream. I don't have it available live on my laptop, but if you go there, it's getting quite hot in here. We started at around 90 degrees, and we're already at 23. So I'm feeling the temperature right now. But it's actually working. So it's pushing the data to the data marketplace every 5 minutes. Did somebody in here look it up now? Did you see the stream? What's the temperature right now? Oh, okay. Oh, yeah, just before 23 degrees, yeah. So also the streamers, if you go to the data marketplace website, you can actually get that data right now, pay with test tokens, and see the data as it is presented by the Raspberry Pi, which is doing a nice job in here, but yeah, I hope it doesn't fall. So this is the actual sensor measuring the temperature in here and put it on the data marketplace. This is the large screen of it, so people at the stream can also see it. And it's actually very simple to build. You need a Raspberry Pi, you need the sensor. I soldered it because I had to solder some plugs on. You need the software for the data marketplace, which is not public now, but it will be public soon. So that will be end of December, beginning of January. So if you're in the Slack, it's soon, dumb soon, whatever you want. But it will be available soon, so the API for putting it on the data marketplace will be available. And the same thing with the charge station. What we did before is, with the charge station, we moved the proof of work, because you actually make a transaction by putting this information on the Tangle. We moved the proof of work from the Raspberry Pi in here to the node. So that allows low CPU power devices to send data to the Tangle, and they don't have to have a huge CPU power to do so, because we're moving the proof of work to the node. And that also scales, because you can have multiple sensors just connecting to one node, and they probably won't send all the information at the same time to that node, so the proof of work is spread over time. And this is this was before a screenshot I made, but it's already much harder in here. Another cool thing is that the Ruby tag, it uses MEM. It's an actual tag created by Ruby, and it works with MEM, and they are able to have different kind of sensors put data onto the to the Tangle using this MEM. And the coolest thing is that they actually are, and this is an announcement, so you can put this into Slack if you want to. This is an announcement. Ruby is now partnering with the IOTA Foundation, so they are partners, and they will work together to build a dev kit. And it's actually a dev kit for allowing to send data from these sensors to the network. So it's now a partner, and I think the blog post is released before or just after my talk, or maybe later on. But this is an actual announcement, so that's pretty cool. And I think that also shows that IOTA is looking for real practical implementations. It's not a cryptocurrency alone. It's also real use cases with real sensors which are developed mainly to do these kind of things and put it on a Tangle. And that's what I like most. It's really cool. This is how one of the sensors look like from Rouvy. So it's pretty small. It supports Bluetooth, I guess. It was in here. So it supports Bluetooth, and you can send it via Bluetooth, for example. Probably maybe the dev kit also Wi-Fi, I'm not sure. But it's pretty small, and it doesn't have to be computational powerful to send data to the Tangle, because again, the proof of work is moved to the node. So now I want you to start experiencing something with MEM. And of course, this slide will be online, so you can do it at home too. But what I want to do is, I want you to create an MEM channel or a stream, which you can send data to, and then you get the root key, and it's all in the Node.js if you open it, and you can actually fetch that data out of this stream. So if you, for example, send this root key to one of your neighbors, they can read everything you put on the Tangle using that key. So if you follow these steps, so there's some free time now to do so. If you follow these steps, you can get this working, and you can experience yourself using this code. How to use MEM on your own laptop using Node.js, and you can see actually how simple it is to do so. So what it does is, it publishes this information using your seed, and you just come up with an 81-character seed, which you don't use for anything else. It uses that seed to publish, and it gives you a root. And that root key, the first one, can be used to fetch all of these messages in the Tangle. But if you, for example, published already 4 different messages, and you give away that root, from that on, only the next messages are shown and not the old ones. So this, somehow, if you have the private one, not with the public one, but with the private one, this gives forward secrecy. So this allows to give away root keys to somebody else, and they can't see the past, but you can only see the future. So you can do this right now. Download the code, fire it up, and if you start with the second step, if you leave the root as it is right now and just try to fetch the information, just run it. So run node fetch async.js. It will actually fetch the information I put on 2 messages before the meetup, so you can test if it's actually working. Question? This is awesome. I can throw this at you. Wrong one.
Yeah, I have one question about MAM. It's just on my mind. When a snapshot happens within the Tangle, you know, like all the transactions are being pruned to just addresses and balances. Does that mean I have to give away another root key? So let's say I give you my first root key, and after like a while, snapshot happens, boom. And do I have to give another root key?
No. I think there are 2 answers. If you have, for example, some perma nodes which stores all the information, you can just fetch everything, but you probably need to query another server. And the program, how it works now, if you publish something, it looks up if you published before and starts at that index. So it will start at a later index, and depending if you work stateless or stateful, it depends if you do that. If you start at 0 again, or if you just start where you were before the snapshot.
Yeah, I think you have to start where you were, because
exactly.
Otherwise you're reusing.
I think so too.
Yeah, okay.
I think so too. But good question. Andreas, still in here? Do you have any answer to that question? Can you put the microphone, the normal microphone on? I think it's on now.
So I didn't catch that question, I'm sorry.
The question was, if you have a snapshot, all of these messages of the MEM stream will get, not deleted, but will be cleaned up. So where do you start with the new root?
So pretty much where you were starting at before. Like, you know, each MEM message will always point to the next root. So you just follow that and you don't stop. At the same time, you know, there's this whole concept of perma nodes which are being developed, which will offer you, which will provide you with a permanent view of all transactions, even beyond snapshots. So you will always be able to reconstruct the data in an MAM stream.
This is a very quick question.
Maybe take the cube so the live stream viewers can hear you as well.
Yeah, good one.
Could this be an extension of the Tumblr function?
Of the what?
Of the Tumblr function? And basically that you could take something where you had a stream and you had data in it and then you go ahead and scramble it and give it a new root key?
So that's not really how MAM channels work.
No, but I'm saying this is the question. I'm saying if the question is basically how do we, if there's the continuation in a MAM channel of somebody who had information based on the prior route, and you want to kill them out of having that information. Mm-hmm. That's what I'm understanding is the question here.
Oh, so if you just want to make it, if you want to make it impossible for someone to continue reading an MAM channel,
yes,
then you can just change the side key, and like there's a side key involved. Like I think it's on your first slide, right down there. There's essentially a side key which is also hashed together with the root to determine where things are attached, and also how to determine the
okay, but if they have an offline copy of the data and they have a decryption key,
not if they don't also know the side key.
Okay, but I'm saying if they
right, you're saying that essentially they could try to crack it.
They could crack it if they have a if this is supposed to be able to work offline.
That depends on how big your MAM channels are, I guess. Like you know the root is not constant. The root changes.
Yeah, but what I'm saying is that if I have got the prior sequence.
But if you have the seed, you can access everything. No. But if you have the prior root, then of course you can.
Everything that had happened before in that MAM stream should be something I should be able to get into if I have it offline.
So there's not necessarily there's no direct link between roots.
Okay.
Like the roots are essentially just the root of a Merkle tree that you generate on a sequence of addresses.
Yeah, but say okay, Monday, Tuesday, Wednesday, Thursday, Friday, I have different roots each day, right?
Maybe.
Okay, so I have an offline copy of all the same data. I have all the same root keys from those days, and I can probably browse back.
But you don't reuse roots.
No.
Okay, but what I'm saying is, if it's offline, you're not reusing the root at all.
Maybe we should move this question to offline. If you do it,
but yeah,
that's fine.
Okay.
So.
Yeah, sure. Sorry. Good one. You can throw it. Sorry?
Who's?
Yep, thank you.
Sorry.
Anybody in here able to fetch this 2 messages on the stream? Fetch works? Okay, so now you can send the information yourself if you do step 1, but you have to put in your own seed, so you don't give away that seed. But if you run it, you will see this is your first root. And if you give the first root to your neighbor, for example, if he puts that root into the fetch async, he can fetch your messages in that stream. So if you add more, you can fetch all these different messages. And maybe this is something you can also do at home, offline, so if you have more time. But we will share the slides, of course, because this enables you in a very easy and quick way to experience how MEM works. And to experience also how easy IOTA is with JavaScript. So that's what I like the most. I tried Ethereum a few times, Solidity, but yeah, it wasn't pretty hard for me to do so. But this JavaScript actually is quite easy. And if you see the example code, you can edit some things and do it yourself. So you can actually see that it works, how it works, what is being done. And if you want to view the Raspberry Pi with the sensor, you can come here and look at it more closely. And maybe hold it, so... I can see my body temperature right now. Any more questions about MEM? Especially about the code? Okay.
Destination and source files.
Durf ik nu niet zeggen. Yeah. But the fetch still works.
Yeah, but it's very slow right now.
Okay, yeah, it's very slow. Probably because everybody is using the same server right now, sending data, fetching data. So you can try this at home for sure. Just make sure you download the code from IOTA meetup.nl. So if there are no questions, I suggest we do. You can still sit here and do this, or go to the bar for a. Are we moving on right away? Oh, we now already. Okay, we do the Q&A right now. With Andreas too. Perfect. Okay, we do the Q&A right now about IOTA and anything you want to ask about IOTA. I think Andreas will join us. Yes, perfect.
So, questions?
Yeah, we don't go.
Yes, lovely. Let's
Any questions about IOTA?
It should say carrot. It says cat.
Who is the first one who wants to ask a question about IOTA? And not about speculation or whatever. Prices.
Yeah, so I can't tell you anything about price, about upcoming news releases, or
Q.
No, I think someone else has got to get a tattoo.
So my question
I think
is...
the discussion was on the face. So,
I saw your slides. You said it's IOTA is quantum resistant. So can you elaborate a little more on that?
Okay. So essentially the way we're arguing here is that at the core of things is a hash function that is quantum resistant. Does not satisfy you.
I didn't get it.
Did that answer your question, or?
No, I didn't really get. Maybe you can explain a little bit more, because my limited knowledge about that.
Okay, look. Let me try to recap that. So at the core of things, if you look at the white paper, there's a certain section about this, and at the end of the day, what we're saying is, if you're like the hash function that we're promising to use, at the core of things, if you use a quantum computer to crack it, you will not get a noteworthy speed advantage, and that's how we're arguing here.
So actually, it can actually crack it just like.
Well, we're saying quantum resistant. We're not saying like we're foolproof.
Okay.
We're just saying that you're not going to get any serious advantage.
Andreas, is it quantum resistant because of the Winternet signatures, the one-time signatures?
That also plays into it, but it's not directly relevant here because that's more an implementation of the whole thing.
Okay.
More. Sort of explain this a little bit more.
Please do if you want to.
More questions? Just raise your hands in the back. You can throw it if you want to. Just make sure you throw a bit in the right direction. Yeah, perfect.
How about smart contracts?
See, I told you, I wrote the queue up there, whatever it may be, and but I can't tell you more about it other than that we're going to be releasing something
soon.
All right. How about timestamps then?
Right, so timestamps. Okay, that works. I'm not sure if you've been following the development of things, but at some point, 2 or 3 months ago, we added something, attachment timestamps to transactions. So you don't just have the bundle timestamp, so when a transaction was created, but also when it was attached to the network. At least when the device attaching the transaction to the network locally, whatever time it thought it would be, was the correct time at that point in time. And then we're currently running analyses of these timestamps to figure out whether everything's happening in the way we envision it to be and whether we're confirming things. And eventually, in the not too distant future, we'll be going to start enforcing timestamps, yes.
Which is nice. There's another question, I guess.
Yes, you've shown us the use case of flash channels. Could you give us some more use cases?
More use cases of IOTA?
No, of the flash channels.
Of the flash channels. So, well, at the end of the day, it's whatever use case you can think of where you need microtransactions happening at a very high frequency. So if that is, for example, as I said earlier, this airplane situation where you're paying per kilobyte and you want to do, and you only want to pay per kilobyte, then that's good. Then you can just do all these. So the thing with flash channels is that all of these transactions happen off the Tangle. Like any party that's involved in a flash channel can always attach a transaction to the Tangle and thereby close it. You can also just like the value proposition here is that you can just do all of these transactions in almost real time without having to wait on any network or any external party.
So it increases the speed of confirmations? Or?
Well, you don't need to wait for confirmations, so yes. I'm looking forward to that.
Sorry,
maybe use the cube later on when you get it. Sorry, I'm not. It's just for the live stream.
Yes, we should use the cube. Let me get it.
We should use the cube.
Thank you.
Yes. Okay, sorry about the bump. But basically, assume that if I'm somebody who's going to be on an exchange and I'm going to be trading with an exchange for getting currency for a period of a day or something like that, I could set up a flash channel on the side with that exchange for moving transactions in and out, and then I don't need to worry about talking to additional nodes for today. Would that be correct? That I could go in and out quickly on an exchange without having to have confirmations?
Yes.
Okay.
If I got your question correctly.
So yeah, instead of the idea of that, basically every time I transfer in and out, I have to talk to 400 or 500 nodes.
Yeah. Well, even in this case, you don't have to talk to even in a regular network case, you don't have to.
Yeah,
talk to
but I'm just saying I could make it faster.
Yes.
Yeah.
That's you don't need to go round trip to a network. Yes. Maybe you wait for the cube. I know it's a nuisance.
That is very cool. Where do we talk in this thing? Hello? All right, this side. So my question was, you explained earlier with the flash channel, you said, well, if there's any funds left, you just have to sort it out with your friends. Now, let's say I'm trying to do a transaction with somebody who might not be my friend, but I still want to do a transaction. Is there any way that, how do I make sure that if I don't know, I funded the channel with 100 IOTA, and then I made a transaction for 50 that I get my last 50 back? Is that when I close it, it's closed, and then how do I know where it is?
Well, so the remainder of the funds are still left in an address that is controlled by the different parties of the multi-signature address, wallet, whatever. So you will need to come to an agreement.
Okay.
Yeah. If it's just a regular one-by-one transaction, you can always have some third party that's doing escrow for you, I guess. And if you then provide that party with all the facts and all the proofs, then that party can help you release the funds if they accept your case.
And then you could also have like 2 signatures out of 3 persons?
Yeah, so there's M2N, which Multisig essentially supports as well, yes.
That's pretty cool. Thanks.
Hi. I've heard multiple times that the network needs to be large enough in order to have high performance. So how big is big enough?
How big is big enough? Good question. Big in this case essentially is determined by a matter of the total hashing power of the network. So if you had, I mean, given that each individual participant in the network, that is, each device does, in an idealized world, proof of work on their own. That essentially means that all these individual small devices contribute to the global hashing power of the network, and thereby it becomes more and more difficult for an attacker to rewrite history, or at least to confirm transactions that shouldn't be confirmed because they're invalid, double spends, whatever you want to call it. So I can't provide you with the right numbers for this at the moment, but it's still going to be a few more weeks, months. We'll see.
Okay. And maybe it's a bit of a related question, but IOTA is supposed to be more scalable than normal blockchain. Can you elaborate on that?
Right. So that's essentially based on our concept of you don't have centralized consensus, but you have consensus happening in different clusters around the network. And thereby, if you have funds in these clusters, and these clusters then do their own confirmations, that way you can scale horizontally, so to speak, because each of these, the clusters won't have to wait on each other.
Okay, thank you very much.
Hello. Question about updating the underlying protocol. So with blockchain-based currencies, you can update the protocol by forking the network. How would this work with IOTA and with the Tangle?
Well, as we've done before, we do a snapshot, and we'd release a new IRE version, and you would have a new transaction structure.
Yeah, okay. And now snapshots are coordinated centrally, but in the future, you can do your own snapshots whenever you want. So, so how does this then relate to updating the network? Is it still updatable? the protocol, I mean.
That depends. I mean, I see where you're coming at this. We're not sure whether that case will arise. It probably will at some point. We're hoping that the final design that we're going for at the moment, which is not the current structure either, will be future-oriented and future-resistant enough. Like, if you look at our current transaction structure, there's very little fields that contain unnecessary metadata. It's all very there's not a lot added on top of what you utterly and ultimately require to route transactions through the network, to send them, to identify them, and reference them. So maybe that case won't arrive that after we've done our final thing, we'll have to update. But if we ever should have to update in that case, then yes, we'll have to figure out a solution. I'm not aware, well,
I can imagine a situation far in the future, maybe, where the hash function has to be updated because it's outdated. That happens to hash functions.
Yes, of course. Right? So what you would probably have then is some kind of transition period or similar, during which you solve this problem and accept all approaches as well, and then you will have the network accept moving on to something new. Then, arguably, of course, it becomes a complete separate question of how you're going to update all these IoT devices. You can have protocols and standards identified through the network, essentially, that tell devices what the current version is and stuff like that. this goes like the actual update or the actual code that's running on devices at the end also partially depends on implementation details of these devices.
Okay. I have one more question about MEM. What happens if I spam the network with big chunks of data? So I'm going to stream movies on the Tangle and go.
Well, if you've got the computing power to do that, I guess that's possible.
So
like at the moment, a transaction can contain about 1.2 kilobytes of data.
Ah, okay.
So if you then
there is a restriction.
A transaction has a fixed size, and each transaction requires proof of work before it's accepted by a network. So yes, there is a restriction.
Okay, thank you.
I hope that didn't hurt.
So for viewers at home, someone else got a cube at the back of his head. Anyway, back to the question. Speaking of MEM and all the data that gets onto the network, so someone was suggesting streaming movies, but just genuine, temperature data. So there are like 1 billion devices in the world that stream their temperature every, whatever is practical. Then you're going to have a huge amount of temperature data,
right?
That's awesome. But it's a huge amount, probably.
Yes, sorry. That was a good joke here. Quite independent of regarding huge. But so the thing is with all these data transactions is that they don't contain any value, right? So nothing, there's no real guarantee, and there's also no economic incentive for other parties to necessarily broadcast them throughout the whole network. So there always might be nodes that decide, I'm not going to hold on to these zero-value transactions unless I absolutely have to, unless, or starting if they're ordered at a specific point in time or similar. So,
okay.
If you're looking at this economically, there's no guarantee that these transactions will be persisted until eternity.
Okay, what is it called? IOFS or something? No, there's some kind of distributed file system that's.
Planetary file system.
Yeah, that one.
Okay. More questions? One here. In the back too, or? Okay.
I have a question about flash channels and winterness addresses.
And what?
Winterness addresses, winterness signing.
Yes.
If you sign once with a winterness address, it's still very unlikely that you crack the private key, right?
Yes.
Is that still true if we have quantum computers?
Please do.
Yeah, throw it.
And you've been wanting to reply to that beforehand as well.
Yes.
Okay, the idea is this. It goes back to the idea of the IPsec, and the way that we used to do IPsec is the fact that you would say that there would be a limit on a session key between two parties that were talking that would last for either 60 minutes or 100 megabytes. And then it would rekey and do a rekey process every 60 minutes or 100 megs. In this situation, because of the fact that you're talking about that the key happens for every transaction, you can take and you can basically save it each time that you decide that you're going to do another transaction, whether it's going to be 2 minutes or whether it's going to be 10 minutes or whether it's going to be 20 seconds, you're going to be able to take and save it, whatever data that I'm putting off to the side out of this, or otherwise, I'm going to be able to say that it holds a different key and a different modulus for all the encryption that happens of it. So the idea is that basically, even if you do have a quantum computer that can crack it, It's going to have to be for whatever size of data that you're going to be transporting back and forth. It's going to be able to crack that data open at a frequency and speed that it will be able to get you more than just a piece of what's supposed to be sent back and forth.
Okay.
Make sense? Okay.
Next question.
Hopefully simple. Question. Still wrapping my head around it. With the permanodes, with the pruning, how do you prove the integrity of the data if the other messages that you deem irrelevant are removed from it? So I have a temperature sensor, it broadcasts every 5 minutes. I save all my temperature data, but the tips and the transactions confirming my transaction will be gone.
Well, if you want to prove integrity, then the burden of proof is up to you. I mean, you're interested in integrity, and a node gives you specific data, but maybe that node doesn't own the complete history that this references. So what you have to decide for yourself is how many transactions do I want to go into? Do I want to be able to go into the history before to determine whether I accept this as whether I accept that this transaction or your data has enough integrity. So if your node doesn't hold it, then you will have to retrieve that from somewhere else.
True, and I want to do the best I can, but I don't have terabytes of storage space on my permanode. So to have a simple data logger.
Right, but like if you're owning that permanode, then you can always just decide by yourself that you will always persist a specific amount of transactions. And I would argue that given the size of each individual transaction, there is not that much required.
Yes, but how can somebody validate if my enough is enough for him? Because I could spoof quite a tangle, perhaps, that might have no relevance in history. It seems valid.
You mean you can change historical data?
Yes.
Well, but if it's now another party, like you know, each transaction as part of its transaction hash always encodes the other two transactions it refers to.
Yeah.
So if someone else doesn't agree with your understanding of integrity for your data, then the burden of proof is on them to figure out where to else get those transactions from.
And you'd buy a service of another permanode to see if it
I would argue that that person would do so then, yes.
Yeah, okay. So, but then you have a sort of a centralization.
Well, not necessarily,
because
depending on how many.
Because it's not between two parties.
Well,
depending on if you steer it towards two parties specifically,
yes.
That would be the answer of yes. But if you took any, if you steered it towards two specific parties, that the answer would be yes. But the trick about it is that if you're going to go random on the nodes, you could do that. Plus, on top of that, each one of the people that you would talk to would have to figure out how to get a cryptographically correct interpretation of something that would represent integrity. So that would take quantum computers to be able to figure out the backward step of producing that, and they still wouldn't probably be that fast.
If that answer works for you, it certainly does for me.
More questions? Anybody?
Anyone up there on the first floor?
Yeah, but they use the mic from the sound guy. We're not going to turn it
Okay.
Yeah, I'm not going to turn it
Why not?
Maybe one for the video, but then...
All right.
No questions?
No questions?
Okay.
No. Well done.
Okay,
thank
you. Then I have some cool video to show. Let's see if we didn't test the music with this one. There's no... I think we should do this after the break. Let's do a break, come back. Or if you have a... The video isn't showing, so I think we should do a break first. A small break, fix the videos, and then come back.
Okay, so we come back in 15 minutes. At 9, and then we will talk about Blockchangers Hackathon.
Electric car. Using solar panels and windmills,
Ik heb een ingewikkelde vraag. Je mag voor mij
Wat was die korte vraag? Ja, nee, dat is helemaal goed. Ik ben promovendus aan het MSS. Ik werk bij een stichting die heet de DICA, het Dutch Institute for Clinical Auditing. En wat ons grote mank is, dat alle ziekenhuizen hebben hun eigen data in een ziekenhuis liggen. Het wordt nu naar een datapartner gestuurd en die heeft een bewerkingsovereenkomst en die data wordt anoniem gemaakt en zo krijgen wij de data dat analyseren kan. Dus dat je denken, nou, met IoT zou je data over en weer kunnen sturen, maar dan zit je nog steeds met het probleem dat de data niet geanonimiseerd is. En ben je bekend met het concept van linked data? Ik had al gehoopt dat je dat was.
Als je eerst uitlegt wat het wel valt, maar...
Ja, linked data is eigenlijk het semantische web.
Ja.
Waarin alle data in triples wordt beschreven. Gaat dat een beetje?
Ja, semantisch web wel.
Ja, precies. Ja, zo kun je ook data inrichten. En, en daar heb je een taal voor, een query-taal, een Sparkle. En daarmee kan je zoeken. Dus mijn gedachte, zou je niet al die ziekenhuizen hun data kunnen inrichten op de linked data manier? Ja. Dat je via IOTA, met Sparkle Language, gewoon als een message je query opstuurt. Dat die automatisch gedraaid wordt in het ziekenhuis en je krijgt je resultaat terug. Waardoor het resultaat in die ziekenhuizen blijft. Of de data blijft in het ziekenhuis liggen. Alleen het resultaat komt jouw kant op. Het is best interessant om daar over praten. Ja. Dus dan heb je in principe een message. Ja, als je die automatisch ergens van de node afhaalt en dat in laat lezen in het programma wat dat Sparkle, of die link data Sparkle krijgt. Dan krijg je het resultaat, kan je weer terug over de nodes naar je bedrijf sturen.
Wat voor data zou je nu sturen is de vraag? Hoeveel?
Nou ja, ik weet niet, dat weet ik niet zo goed. Maar wat zou kunnen is bijvoorbeeld je vraagt, ik wil van jouw ziekenhuis alle mannen van 33 tot 35 jaar hebben die met de ziekte van dit. Hoeveel een percentage, want dat zit dan in je berekening van je query.
Maar die kunnen ze dan zelf lokaal draaien?
Ja, bijvoorbeeld. Ja, die kunnen ze dan lokaal draaien en dan krijg je het antwoord, sturen zij dan als message terug.
Je zou dus ook een vraag kunnen stellen.
Ja. Dat is interessant, toch?
Ja, dat is een interessante vraag, ja.
Nou ja, misschien om iets mee te doen.
Ja.
Denk er nog even over na. Misschien als je iets bedenkt, dan...
He has worked as a lecturer.
Als het gaat om leven, dan maak ik een transactie en dan hebben we die handshaking dus die Jovers wordt afgeschreven en dan krijg je maar de dat zou wel makkelijk zijn. Dus dan ga je dus niet op dit werken en dan moet je weer verlenen. Voordat je naampas maakt, wat je ook zo doet, is de auto. Een flesstellen maken. Dan kunnen ze per dan stonden wij in 6 zakken. Dan stop je rekent een kwartje af. En als dat binnenkomt, dan je vertrouwen krijgt. Dus je zit gewoon lekker in je eigen kookveld van
Ik doe even handjes.
Ja. Ik ga dadelijk wel van. Ja, is goed.
Ja, voor mij, ik heb gewoon een algemene vraag. Dus meer hoe IoT überhaupt kan werken. De hoeveelheid transacties die er staan. Het Intel is waarschijnlijk meer dan 1 computer aan.
Ja, precies. En dat is wel... Ja, wat je voordeel hebt, wat je bijvoorbeeld bij Bitcoin zit, heb je blocks, dan heb je die blokken en dan bij IoT is het gewoon een constant stream. Je hoeft niet te wachten. Uiteindelijk heb je natuurlijk wel niet een fysieke limiter, een fysische limiter, dat je niet gewoon meer data dan je krijgt. Of die node niet meer data kan verwerken. Dus daar zit je wel aan, maar dat is vele malen hoger dan dat je nu een andere...
Ja, nee, dat geloof ik zeker. Maar het is ook naar machine to machine.
Ja, precies, dan krijg je veel data.
Dan krijg je heel veel data. En ik vermoed dat natuurlijk een deel van de meer dan initiaal kan.
Ja, maar niet alle nodes alle data moeten aanpassen.
Maar het gaat niet over data, het gaat ook over de IOTA-transactie zelf. Als ik heb op een goed moment mijn wallet, daar heb ik wat IOTA in zitten. Nou, dat is te controleren van hoeveel zat er op dat moment in. Als ik het dan met 2 partijtjes doe, dan moet jij, als jij zeker wil zijn van mijn IOTA, ook een andere plaats op een manier binnen.
Ja, dat is... Ja, maar dat die notes dat samen zouden moeten doen. Maar dan denk ik als je...
Ja.
Stel dat krijg je echt een
beter antwoord. Ja, precies. Dat probeer ik wel.
Wat ik allemaal kan zeggen. Ja.
Ben ik? Ben ik te laat?
Sorry?
Harm?
Ja.
Ja, te laat?
Sorry?
Micha. Of Henry.
Henry, ja, dat kan.
Ik heb namelijk nog een vraag
over de code.
Man.
Kan we dadelijk nog
Dan
hebben een achtertuin. Hij is privé. Alles wat je hier hoort, hij moet... Ik heb niet iets met deze kant. Dus als ik hem uitzet hier, ga je bij hem aan. Dus hij staat privé.
Het is niet heel goed voor smart contracts. Is het binnen
Die zeggen ja, dat is toch zo. Ik weet niet wat ik mag zeggen allemaal. Ik weet er wel niet van. Ik weet dat er een soort van is gedaan, maar ik weet niet wie er gedaan. En ik zie er ook wel eens komt eraan, dus daarvoor mag ik zelf. Nee, ik kan het niet net voor een prestatie doen. Misschien als ik het morgen heb, dan zie ik het ook. Erik, dat is ook niet.
Wat zijn er in die
helemaal vraag. Ja, een hele goede vraag. Ja, een makkelijke vraag. Ik ben absoluut geen intelligent mannetje. Ik heb een beetje random op iemand de tip gaf, IOT is goed, nou, heel mooi uitgepakt. Alleen, waar ik denk, is er ook een plek waar je bij uitspreken Jip en Janne totaal theoretisch het idee van, ja, kijk, dit gaat al best wel hoog opgeleid, maar dit gaat al best wel wat. Ik denk ook dat een gedeelte van het succes hangt af dat je dit aan de bakker en de slager de hoek kan uitleggen. Maar ik kan zelfs naar de universiteit of vrienden, kan ik niet uitleggen hoe dit werkt. Ja, er is zo'n plek waar dit helemaal is geschreven. Als je mijn naam zoekt, had ik een blogpost geschreven op wat de mogelijkheden zijn om dit soort netjes in lekkers te vinden. Internet is wat makkelijk uit te leggen. Zo'n animatie is, weet je wel, dat je zegt van een sleuteltje hier en een... Maar dat juist de dagelijkse man kan begrijpen. Hey, we hebben nu een videootje, ik hoop dat het iets duidelijker maakt, maar het is niet de techniek zeg maar zelf met sleuteltje. Ik denk dat daar, als je de dienststap kan maken, dan heb je echt een grote team. Er zijn al video's die van ja, ik heb die voor mij gezien. Ja, die zijn best wel begrijpelijk. Begrijpelijk wel. Ja, begrijpelijk. Tot succes. Ja, dankjewel. Succes met je presentatie.
Okay. Let's start again. I think most of the people are back in. Yes, thank you. I want to start with the video. Last meetup, I showed the IOTA charge station. So you can charge your electric car using the IOTA charge station. And then IDNL, so the foundation founded by all the Dutch grid operators, we look at disruptive technologies like IOTA. So we also made a video about IOTA and distributed ledgers and how this might change the world of tomorrow.
One trick would be to just mic the computer too. That's the next trick.
Let's see if this turns up. Yes.
Generate our own renewable energy.
Let's say you work from home today. Your electric car is parked outside and is charged by the overcapacity from the solar panels on a nearby school. In the evening, the energy stored in your car will now power the lights in your house. And together with other nearby cars, you might even be providing the power for a concert in the local park. Throughout the night, windmills located just outside the city will refill the car batteries. So in the morning, you leave for work fully charged on renewable energy. To successfully automate this whole process, both data and value transactions have to be calculated for every exchange between these devices. In the future, these will increase exponentially. The old approach of registering every electricity exchange centrally and then paying through the bank afterwards is not particularly appropriate for these kinds of microtransactions. Luckily, there's a new thing as well: cryptocurrencies. These are way more suitable thanks to the underlying distributed ledger technology, or simply DLT. It is secure, transparent and peer-to-peer, and supports both data and value transactions. The best known DLT application is the Bitcoin, but because of limitations in its technology, it's not really suitable either. But hang on. Recently, better alternatives have become available. One of them, IOTA, makes use of the Tangle, a new kind of technology, which is ideal for these microtransactions. It is fast and costs close to nothing because the users validate all the transactions themselves. It's an ideal, decentralized approach. To explore this possibility, we've built an IOTA charging station prototype, where you can use IOTA to pay and charge. No need for a card or subscription. When connecting cars, solar panels and windmills to the IOTA network, all these devices will be able to sort out the transactions and their related payments themselves. It's easy, safe and reliable. Exactly what we need to live in tomorrow's smart charging world. Join us in further exploring these exciting opportunities. Let's co-create. ALAD NL researches and tests the possibilities for smart charging on behalf of the Dutch grid operators.
Yes, that worked. So what ALAD does is actually looking how you can improve the system like it is now. And if you want to have more sustainable energy, like solar energy or wind energy, you want to have these microtransactions. For example, you want to buy your neighbor's solar energy, or you want to sell your energy from your car to your neighbors. And in the future, we probably need a system to support this. And at ALAD NL, we look at these technologies, and one of them, of course, is IOTA. So that's why we created the video. I hope you liked it. And it will be available on YouTube, so you can watch it at home too, with proper sound, I hope so. So now I will give the stage to Jan-Peter. Oh, 1 minute. Is there anybody who has a question about ALAD, for example, or the charge station? Yes, up front.
Well, for this to really work, there needs to be a difference between the price in the day or in the price in the night and the price for charging and the price for discharging. And at least the bigger players on the energy market don't do that now. Have you seen any initiatives where that is more fluent or during the day, or do you see that changing?
I think there already are companies that allow for changing prices during the day. For every quarter of an hour, for example, the prices change. And I think you need these kind of things to that the prices changes every quarter, for example, to support sustainable energy more, because you want maybe to charge your battery in your home or your battery in your car when the prices are cheap. And I think the system needs to change in that way, so that's why we call it a transition, an energy transition. But yes, good question, and that's what we need to see if this evolves into these kind of systems. And I think IOTA can help with this, for example, to support this. Jan-Peter, you're set up? Yes. If it doesn't work, just put your microphone.
Yeah. Okay. Welcome. As you noticed, we at ALAD and Enexis, we really like to look at new technologies to understand how this can change the world. And in this last part, we're going to take that one step further. We're going to tell you what we would like to do with you on the biggest hackathon, blockchain hackathon of the world. It's the Blockchangers Hackathon. It works with a number of pre-sessions. We, a few weeks ago, had the tech deep dive. And I want to show you a 2-minute movie, I hope it works, of what happened there.
But the thing that we have learned until now is the technologies to actually be able to soon. So that means that every initiative that is aimed at accelerating the pace towards that is actually bound to be successful. What implications does this have for, let's say, the average citizen of the world? Many implications, but very fundamental ones. And one is, right now, we are relying on energy resources that are owned by very large institutions, you know, that they plant flags on an oil field somewhere, and then they say it's mine, and then they're gonna define what the price is gonna be, what the availability is gonna be, who's gonna fight over it, etc. That's not gonna happen anymore because the sun is shining on everyone is happy. There's no discrimination. The wind is blowing through everyone is happy.
So, what you see here is that we asked people the question, if you think about the future, what would be your dream? And especially if you look at new technologies and that you understand that in the world of tomorrow, machines are going to interact with machines. So, what happens then? What could be possible? Basically, machines interacting with machines is that we, the developers, have the choice on which system we are going to build it. And that will be our question in the blockchain hackathon. As Harm already told, Harm and I, we are both a part of a grid company. And what the grid company does is that we basically own all the electricity cables and the gas pipes in the ground. And for a very profound reason, a few years ago we sold away our energy companies, and they could be well sold abroad. They are almost all sold abroad. And what we found very important is that we ensure the right to energy. And owning the grid, even if the energy companies are in the hands of foreign nations, owning the grid is a very good way to ensure that you always are a part of energy transitions and everybody has a right to energy. But if you look at the world of tomorrow, then you see, for example, big companies like Uber, who have in their end game, in their vision, they want to be the utility of transportation. That means they would have large fleets of self-driving cars. Those cars are all paid for. And in the evening, when they look at those cars, they stand still, because there isn't a need for them. There are no people to drive around. So what could they do with those cars? They could start driving energy around. And then we, as a grid company, have an issue, because we are there to ensure that right, but we are basically monopolistic. That means that we are not built to compete. My name is Jan-Peter Dominik. I work in the Department of Strategical Transitions, and what we do is to find the questions nobody asks. And one of those questions is, how can we build solutions that will help us ensure that right to energy? And that is one thing we want to work on you together. Says, a blockchain will help us build a programmable economy. And in those programmable economies, there are totally different business models, if they are business models at all. There are totally different ways of interacting. So what we're going to do, as an example, is look at an ecosystem that operates at a level that no company can compete, to give you a feeling how crazy it could be. And as soon as you have that feeling, I'm going to talk 2 or 3 steps what we want to do in a hackathon. The crazy thing, if you want to talk about the future, is nobody knows what the future is going to bring. But what we can do is we can go back 20 years in time and look at the world from the perspective of 1995. And for example, imagine that you have a CD store. Then in 1995, people tell you about that crazy new invention that was called email or the internet or something with www, but it was something new. And especially that email thing was very cool because you could send messages. And there was some technical guy that explained them that you could look at your computer and it is as if you have an additional drive, and every file you put on that drive can be accessed from everywhere in the world. And then you say, okay, I have a new, very hot application, email, and I have some technical explanation like an additional drive, but I sell CDs. How could it change the world for me? And then if you could talk to that guy in hindsight, then we would tell him, well, the first thing which will happen is that people build stores on the internet, like bol.com. And bol.com will have 1,000 times more stock than you have. People will use that internet to share the files you sell, like piracy. And then you will have other companies, like Apple, who see that the market is changing and will sell the products you sell, but for a very small price in their app store and direct delivery. And then in the end, companies like Netflix and Spotify will end basically that the thing you sell is a product, but they will sell access to all the products. And if you look at that from the perspective of the CD store owner, in 1995 his first reaction will be, this is ridiculous. This can never happen. This is so strange. And then as soon as he sees it happening, then he will say, this is dangerous, because this will change my market completely. But in the world of today, we know now it is normal because we see it all around us. So let's see if we can do that for distributed ledger technology. And where we start is with the car. Because we all see that cars will be self-driving. Basically, the car is a thing, and we are building it now in a way that itself can deliver all the services that has value for man. So it will drive you from A to B. It can pay for its energy. Once a week it goes to a car wash. And now and then it goes to a repair shop. So basically, the car could be its own economical entity. And it could be that on the blockchain. And now to introduce the very big turnaround in thinking, in the World Economic Forum, they are already talking about self-owned machines. And then something very strange happens in our heads, because a thing has no urge for money. A thing without a company behind it could operate for the greater good. For example, you have a forest in Germany which is called terrazero.org, and their artists built a self-owned forest. What the forest does is there's a picture taken every half year via satellite. That information is analyzed, and it is there's calculated which trees to cut best. These trees, through blockchain application, is sold to a lumberjack who bids the most. Then as soon as they get the money, the forest sells the tree, and with this money, the forest is self-maintaining. So we see the first changes in our periphery just by playing around with ownership and the fact that machines have no urge for money. What would happen if we have a city of 50,000 people and we put in 10,000 cars? Assuming those cars are not only self-driving, but also self-owned, so they have no urge for money. What would happen starting day one is they would offer transportation at 1/5 the price, 5 times cheaper as we are paying today. So if we do a Kickstarter campaign and we say we want transportation 5 times cheaper as we pay today, we are not going to be the owners of the cars are going to be self-owned. We could do that and start in one city in the Netherlands. And then we have to do a trick. What we're going to do is we're going to ask a little bit more money, not because we want money or the cars want money, but a city of 50,000 people needs 20,000 cars to have all its mobility outsourced. And with the additional money, we buy additional cars. And we drive some more and we buy again additional cars. And then something very funny happens as soon as we reach 20,000 cars, because then there's money coming in and nobody cares. And there's more money coming in and nobody cares. So what we can do then to give you a feeling how crazy these economic systems could be is that we give the money back to all the people of the Netherlands as basic income. It's an extremely small amount of basic income, but it is basic income. So we start with a solution that is 5 times cheaper. And all the people are trained by the cheaper solution. And then in the end, this solution doesn't contribute to the wealth of some shareholders, but it starts contributing to your own wealth. So this is a very cool solution. And the nice thing is that the lesson we learned, look at the site, we can repeat, because every machine or every instance there where we were paying money, we can replace with machines. For example, the energy charging point, there's a new technology we're working on, which is called the artificial leaf, which basically takes sunlight and a bit of water or a bit of CO2, and then turns it into hydrogen or methanol. And don't forget that this morning as you woke up, the sun was shining, and it was putting a layer of 6,000 times the amount of energy we need, raw energy, for free, on your roof, on every place. So basically what we could use these machines for is to create energy forests. It's like an energy tree that takes sunlight and creates usable energy. And then something really, really crazy happens if you think about transactions, because if self-owned, self-driving cars drive to a tree and he says, hey, I'm a car, I need energy. And the tree says, hey, I'm a tree, I have energy. They would exchange it. Both entities don't care about the money, so there's no money in the transaction, but there's also no identity in the transaction. Because in nature, and that's the thing you're mimicking now, there's no exchange of identity before you do a transaction. That is one of the reasons we really want to explore this in the hackathon, because machines interacting with machines can create completely new kind of transactions. And the funny thing which is happening is that by replacing our partners by self-owned machines, there is no money needed in those transactions. So basically what happens is that, oh, that's one too fast, is that the money flow grows. The money flow gets thicker because the machines don't have an urge for money, so we give it back to the people of the Netherlands. And then of course, we can do the Uber trick. We have those machines, they stand still in the evening, They are already energy shared. So what we do is we load them up, we drive them around, and we start using them to distribute energy. And then we have not disrupted one infrastructure, but we have disrupted two infrastructures. And let's say that we ask here again 20% of the price, we would have doubled the basic income for the people of the Netherlands. And then, of course, if you look at cars, cars now are built in parts, and every new model has new spare parts. But if we, as a collective, are building cars, we can also rethink how we build cars. Cars can be made out of parts that as soon as they break, we melt them, and we 3D print them again. That means that this whole funny ecosystem has all the technology that is needed on that funny layer on the internet, which we call the distributed ledger. And the only thing we have to enter is raw material. And that means that if you look at it on the right side, if you replace that last place, you've created a completely new ecosystem. Which, of course, if we would look at it today, would say, it's ridiculous. This can never happen. But if we start building it, and if we start proving it, then people will say it's dangerous. And I already look forward to the world when it's normal. Because if you have done this for one city, we have made transportation and energy extremely much cheaper. And if a second city also wants cheap energy and cheap transportation, they cannot go to a company and say, I want that also. But what they can do is to start the Kickstarter again. And the nice thing of blockchain is if you build it on one place in the world, it's automatically on every place in the world. So the only thing the new city has to do is to connect again with the blockchain. And then the funny thing happens, the second city also contributes to the basic income of the people of the Netherlands, and the third, and the fourth, and the fifth. So what you see here is what we want to do in the hackathon. This is just one example of a crazy thought experiment we can do if you think about what would happen if machines who have no urge for money interact with other machines. And this is exactly where I'm going to invite you. The official kickoff of our track in the hackathon is on the 8th of February, so please mark that date. And what we're going to do is we're going to take you on a trip on that day to show you what we can offer you to build crazy new solutions. And of course, you need new narratives, crazy ideas. We are collecting them, as I proved a few minutes ago. What we also are doing at this moment is that we are crawling through the internet, through all the scientific publications, and see what is happening there. And what we're going to do, if you are one of the 8 teams who will participate with us on the hackathon, is that we're going to train with you what happens if the technology that is now at the start of its development cycle, if it's matured, what can this technology do then? So you will have an idea of what the elements are which create the magic in the future. Then we're going to do another thing, and we're going to ask you, okay, we have to spread these new narratives. And of course, the technology is not yet ready. But what we can do is, if we understand the story, we can build a game of it. So at this moment, the people of BigChainDB, maybe you know them, are working for us on the first game, where we look at these new possibilities and think how can we create abundant ecosystems with them. And on the 8th of February, they are going to share with you how they built the game, how they made the game fun, because games only spread if you make them fun to play. And the nice thing we want to point out is that it is the game of tomorrow, but we build it on the ecosystem of today. So we're going to build it in a way that all the transactions are done on IOTA. So that people discover the new narratives, and we discover how we can build it in an infrastructure. And maybe not everything will work, but we will at least get out the research questions that we need to answer to create worlds like this. So, which two dates, if you want to be part of our track, are very important. That's the 8th of February, where we're going to do a session where we're going to show you how BigChain did it, how you can create such a solution, how you can rethink technology. If you need special pictures for your game, we already have artists there who are going to offer their work open source, so your game also looks very cool. And any other resource you can think of today or on the 8th of February, we're going to arrange for you. If you have questions, and we're going to Q&A afterwards, you can ask me. These are my contact details, but I also brought a special guest, Stefan. Stefan is actually one of the organizers of the biggest hackathon of the world. And Stefan, yeah, give it a round of applause.
Thank you, thank you.
Thank you. And Stefan's gonna tell a bit more about the hackathon, how they put the teams together. So if you want to work on this really cool future, he's going to tell you how. But of course,
first a movie without any sound. And actually, when it doesn't work, I will stop the movie, of course. All right, so.
Yeah.
All right, so this is. Thank you. Thank you. Hi, I'm Stefan. I work for DutchChain. It's a startup, and well, we organize the biggest blockchain hackathon in the world. We're going to do it for the second time, April 2018. The first time we did it this year in February. The after movie you just missed, you can look it up on YouTube. I wanted to show you the after movie because, well, it was quite something, and you should be aware that this is not just a normal let's go and meet up with some people and drink some beer and have a hackathon. This is like an innovation program, and that sounds dull. But as Jan-Peter just explained, it's not dull at all. We do this to really prepare to get, and then it's a swear word, and then it's done. So we have 7 different tracks. I'll tell you something about them later. One of them is from Jan-Peter. We have all these meetups. We had a kickoff in the Ridderzaal, the Hall of Knights. We do stuff in a legal deep dive. We've had a funding deep dive. The legal deep dive we had at the regulators, at the AFM, a funding deep dive at Nyenrode. And we've had this technical deep dive with 600 people in the room in Delft. It was really, really amazing having all these tech friends of ours, not only IOTA, but BigChain and Ethereum and Bitonic and Parity coming up and really talking to the ecosystem and really preparing the ecosystem. That's what we do. And then we have one biggest blockchain hackathon in the world, followed up by an acceleration program. I'll tell you something about it later. I'll first tell you about this. In our hackathon, it's about building fully functioning prototypes, building applications. It's not about trading. It's not about all fintech. It's about real life situations with real life customers. So. We've got a track about health. there is our Ministry of Health, and there's the University Medical Center of Groningen, who are dying to find out how can they cope with patient data, but also how can they make medical research more effective. You can imagine there's quite a lot of privacy issues when doing medical research. Well, they want to overcome that so they could, well, basically can do better research. It's quite cool. And we've got energy with Nuon Vattenfall, the Gasunie, and the New Energy Coalition, who are really struggling, as every company is right now, with the GDPR, the privacy thing in Brussels. And they basically said, well, we want to develop this in co-creation with the ecosystem, but not for us, not for all energy companies, but for every company and for every government in the world who is, or in Europe in this case, who is struggling with this. And again, when you come to our hackathon and you build an application which works and which is fine or better than fine, which is great, you can end up having a customer like Nuon or Gasunie. Public safety, well, who better to work with than the Dutch National Police? Well, they've got this thing called cybercrime going on, which they're really interested in. But the one other thing they're interested in is, can we make a blockchain of evidence? Can we really be sure that no evidence has been tampered with? And if we can we build it and can we export it to other countries where maybe evidence is a little bit iffier sometime? Then we've got an interesting track called Digital Nation Infrastructure. Well, every country has these organizations called Chamber of Commerce or Cadastre, the land registry. They're two of our sponsors, and they're saying, I want to bring my entire organization to the blockchain, and how should I do this? And when people build stuff, can they actually make sure that I don't have like a PDF which says, well, I'm a company, but can I get something smart that everywhere in the world people can say, yeah, I'm a company. Basically, that's it. Really easy, but it hasn't been built yet. So you can build it as us, and when you succeed, and well, when they like you, you can get a customer. Then pensions. That's so boring, but well, everybody has one. Not me, but some of you have a pension. And we've got APG, that's the biggest pension fund provider in the Netherlands with like 5.5 million clients. They say, well, why only the Netherlands? Why shouldn't we develop a smart contract so everyone in the world can manage their own pension on our Dutch amazing pension system? It's quite a use case. Then we're talking about the machine-to-machine economy. Jan-Peter told you all about it. And the last one, it's a very special one. I'm not going to get into detail because we can talk about identity in blockchain all night, I guess. But it's called Global Digital Identity. And here we are pulling out all the stops. We are working with the EU, the World Bank, the World Food Programme, the Red Cross, but also with Uport, Sovereign, Materium, etc., all those kinds of experts to make constructive building blocks to finally get something done in this space. All right, so during this hackathon, yeah, so there are 64 teams. I put them in the middle. You see, I'm quite of an Excel artist. And on top of them, there are the launching customers. Of course, that's going to be like a festival, and you're going to win money, and there's all kinds of beer. But you want your solutions to be accelerated, and how can you accelerate your solutions by getting a customer? One other thing, during the hackathon, there are going to be Jedi. We call them Jedi. I'm not, but the rest of the teams are full of nerds. So we call them Jedi. They are experts. They will help you along the way. I just mentioned some names. They will be there to help you. Our tech friends and also these experts I just called on identity. But there will be lawyers too. And actually there are lawyers who know something about blockchain, and they will be helping you on the Friday of the hackathon, not on the Sunday, but on the Friday, and saying, well, maybe you shouldn't write this down like this, or you should do it the other way. Then you don't get into any issues later on. Quite useful. And we've got all these experts, I just mentioned them below. But when you're done, each of the 7 tracks has got a €5,000 acceleration prize. This could be tickets to South by Southwest, or this could be buying the gear that you need for your solution. And each track has 10,000 euro prize money. So there's like 100,000 euro plus prize money in total. And last year we actually sent teams to Consensus, and we sent them to South by Southwest to pitch their solution. Open now. You can register. We have this deadline at the end of February. That's all quite interesting, but we are right now registering teams and we are confirming them. So not everybody can just join this hackathon. We do this thing called curation. It's a bit of a theater term where you look at the strength of the team. Well, obviously knowledge and skill, interdisciplinary qualities. It might help if one of you is a little bit commercial or communicative or a backend developer, or so think about your team. But also, what's your ability to get your solutions off the ground after the hackathon? The best performing teams of last year are right now working with these launching customers or having their own startup. There were amazing teams last year who did a great demo, and when we asked them, what are you going to do Monday? Back to work. We said, oh, no, that's not what we mean. So think about this. If you want to join, if you want to do great things, are you willing to quit your day job and really go with it? And you have to have some affinity with the track. So if you're in the health track, it might help that you get a doctor or a patient aboard, right? That's it. Really easy. And it's time for Q&A. Thank you.
So we have two kinds of questions. If you have questions about the hackathon in general, and I'm a very good programmer, but I'm not part of a team, how can I get joined? Then the questions are for him. If you want to build a crazy future and you are curious in which 22 different ways we're going to help you, the question is for me. Yes, there you go.
Hackathons are usually aimed at programmers. Is there also room for psychologists and anthropologists? Because the forward thinking is needed, and I'm not sure that is the specialism of a programmer or a designer even.
We need, and especially my track, we need a lot of forward thinkers.
And we have experts in all kinds of fields. For instance, this privacy law thingy, of course there are two people coming from the EU who actually drafted this thing. So if you feel you can add something that no one else can add, please sign up and tell us why.
So as an individual, you can also sign up and be part of the hackathon?
We encourage teams to sign up, of course, but individuals can sign up, join our Slack, and then look for a team.
Cool, thank you.
Can you tell me how the IOTA dream is guarded against seizing the ownership of it? Because we see that happening all the time. There's new development going on and new ideas. Back in the 80s, we thought the internet would be like this. And now the States decided to lose the net neutrality.
Net neutrality?
Yes, that one. Yeah. So what's going to happen here?
Well, it would be great if I have the answers, but that's why I want to have 8 teams to come up with a lot of crazy questions nobody thought about. The nice thing is that if you see how nature works, and it works without ownership. So basically what we are looking at as much as possible is how can we use these elements and put them into our solutions. The nice thing is that if you now talk with companies, they think, okay, I have a national market and I can defend it by having good relationship with the politicians and etc. And we already know here that we are building global solutions. So what happened at the legal deep dive of the blockchain was very cool, because you had the lawyer of the state and the AFM who were telling how they curate blockchain solutions, and they really wanted to help to get one solution going. And then there was a guy from America in the room, and he said, you do understand that there are now some technical issues why we cannot all build things on blockchain? But as soon as we're doing that, it's like a tsunami that is heading your way. And you cannot stop that by legal measures. As soon as we have built solutions that, for example, work for free, and that they are on that funny layer which we call the internet, we can either kill the internet or we learn to live with it. So the nice thing is that in the possibilities of the new technologies lie elements that people have not thought about it. And that's why we are the only track that will work open source. So the first question you have to ask yourself is, do you want to be a millionaire? Because then our track is very bad for you. Very bad. But if you want to have some impact on the world and to tell your children about it, then you are the guy for us, or the girl. Does it answer your question?
Not completely.
Let's meet for a beer then, because yes. I have a lot of detailed answers, but then...
That would be great.
Yeah. Another question.
Very small practical question from my side. I've already enrolled for your session on the 8th of February.
Nice.
Is it curated as well? Because you had to motivate it, and I didn't have any feedback on it yet. I'm not sure when that will happen.
It is curated, and yeah, we do this because there's a limited amount of seats available, but also to maintain a high level. It doesn't make any sense to be a novice and go to these events. So
but
I'll be taking a look at your registration.
But if you come to an IOTA session where you bring your laptop and you think that is cool, then I wouldn't worry about that much about your curation.
Okay, fair enough.
So what we need is people with crazy questions. We need people who are really motivated and are willing to look at the world differently. Because what we in our track are going to do is come up with new narratives, new storylines. So maybe it would be even feasible to have a team with 1 or 2 kids of 8-year-olds because they don't see the limitations we have. It's really about looking differently.
Yes, I do have a question. I'm not sure to whom. How do you put the teams together? Because I'm not a programmer. I don't know any programmer. But I do know about the privacy thingy.
Yeah, cool,
I do know about how the energy system works. And, well, I do know a bit about strategy and so on.
Yeah, you sound like an amazing participant. Now, what you can do 2 things. You can sign up on our website and fill out like a job application. Hey, here I am. These are the things I can do. Which team needs me? The second thing is you can go on our Slack and do the same thing there. I can tell you, if you're a privacy expert and if you're working in the energy sector, you're a very wanted person for this hackathon. So don't worry about finding a team.
That's interesting, but I don't know what Slack is. So.
Well, you know Google.
Yeah, I'll try.
Other questions? Do you like the idea of looking for crazy new solutions?
Yes. Yes. Yes.
So even if you have the feeling, I don't know how I'm going to do it, but I like the idea, keep in contact with us. Because we really want this thing to happen, and that means that if we have to do another session, or 2 other sessions, or 3 other sessions towards the 5th of April, we are going to do that. co-creating the future is something you do together. And we need you, because I don't know who's going to have all the crazy questions. But if we work together, if we do not compete, the old economy, the old world is all about competition. Let's show them what happens if we start to co-create. Thank you very much. You want to have it?
Indeed, thank you very much. Thank you, Stefan, JP, Harm, Andreas. Thank you all. Thank you all for coming. Thank you, online people, for following us. It's over, sadly. But, yes, I have a few buts. First but, we have 2 teams of video persons, actually 3 with the live stream team, but for right now we have 2 teams of video person who would like to ask you questions. They respond to the names of Kevin and Martin. So Kevin is the guy over there. He can raise hand. Hey, Kevin. Go with them, go to them, or they will go with you, to ask you questions about tonight. There will be harvests, videos of this meetup, and your feedback will be very much more than welcome. More than that, there is a bar still open over there. Thank you very much for coming tonight. Don't hesitate to share any video, photo thing that you had, and of course, yeah, indeed, program MEM at home. Tell us how it worked, how it didn't work, and tell us why. I think it's welcome. And also, last but not least, your IOTAs, if you want to get them back, follow the small instructions that you have on your paper. And that will be all for me. Did I forget anything? Yeah, of course. This was not the last one. So now is Christmas, and after Christmas is a bit of time for us to program the new application and demonstration and to get better at technologies and sounds and other stuff. So our next meetup will happen in March. The date is not found yet, but it will be soon. So stay aware of what we do and what we share, and we will see you very soon. Thank you very much.